Welcome to Easy Academy YouTube channel. If you are coming across my lecture for the first time, make sure you like the video, share it with others, subscribe to the channel so that you don't miss my upcoming videos. Thanks for watching Easy. In this lecture, I want to examine the mixed constraint using the simplex method of solving linear programming. Mixed constraint using the simplex method of solving linear programming. My first video on simplex method involves the maximization problem, how to solve questions involving maximization. And my second video is how to solve problems involving minimization objective. So in this video, I want to examine the mixed constraint. What do you mean by mixed constraint? Mixed constraint is the constraint with less than equal to and greater than equal to inequality symbols. Any constraints that have both inequality symbols, less than equal to and greater than equal to, such constraints are said to be the mixed constraint. There are two methods of solving problems involving mixed constraints. Number one, the first method is to reduce the available capacity by the amount required to make the unit or to make a unit of special constraint product. To reduce the available capacity by the amount required to make the unit of special constraint product. That is method number one. If this method is used after the problem has been solved, then you will need to add back the units required to make the special constraint product. You will need to add it back to get the optimal production plan. The second method is to multiply both sides of the special constraint by -1. To multiply both sides of special constraint by -1. So in this video, I will consider the first method. My next video, I will consider the second method. What are the steps you need to follow when solving problems involving the mixed constraint where the available capacity will be reduced by the unit of special constraint product? The first step is to formulate the linear programming. Formulate the linear programming objective function and the constraint. That is the first step. So after the problem has been formulated, then the second step, step number 2, is to reduce the available capacity by the amount required to make the unit of special constraint product. Reduce the available capacity of the normal constraint, by the units required to make the special constraint product. By the time we are solving a question as work example, you will understand this better. Reduce the available capacity of the normal constraint by the units required to make the special constraint product. That is step 2. Step 3, introduce the slacks variables. Introduce the slacks variables and then organize the problem into matrix form. And then organize the problem into matrix form. That is step number 3. You organize the problem into matrix form. Step number 4 is to identify the pivot element and then use it to divide every element in the pivot row. Identify the pivot element and then use it to divide every element in the pivot row. So remember to replace the variable in the pivot column with the variable in the pivot row. So you will understand this better with work example. Step 5. Find the new values for each row by subtracting the value or the values in the pivot row from the old value in each row. You should target having zeros in the pivot column, except the value of the pivot element that will be left as 1. It's only the pivot element that will be left at 1. Apart from the value of pivot element, every other elements in the pivot column should be zeros. Then step number 6. Repeat the process until the optimal solution is reached. Repeat the process 1 to 5 above until the optimal solution is reached. I've told you that the optimal solution is reached at the levels where all the values in the objective function row are either zeros or negative. Every element or values in the objective function should be 0 or negative value. So at the point where all elements in objective functions row are zeros or negative, then you know the optimal solution is reached. These are the steps for solving linear programming involving mixed constraints with the first method. Example: objective function. Maximize 5x1 plus 3x2 plus 4x3. Subject to constraint A, 3x1 plus 12x2 plus 6x3 less than equal to 660, which is machine hours constraint. Constraint B, 6x1 plus 6x2 plus 3x3 less than equal to 1230, which is labor hour constraint. Constraint C, we have 6x1 plus 9x2 plus 9x3 less than equal to 990, which is component constraint. Component D, we have x3 greater than equal to 10, which is sales constraint. Non-negativity, x1, x2, x3 greater than equal to 0. x1 and x2 and x3 represent units of production, units of product A, B, and C. Now, this is the question. Now, let's have the solution. If you look at this problem, this is a mixed constraint with constraint A, B, and C having less than equals to inequality symbol, which is maximization constraint. Then constraint 3, x3 greater than equals to 10, which is minimization constraint. Your quantity x must be greater than or equal to 10. Now, since these first three constraints is having greater than, is having less than equals to, and the fourth constraint is having greater than equal to, this problem can be solved in two ways. But we want to reduce the capacity of the special constraints by the amount required to meet the units of the special constraint method. So we want to use that method now. Let's have the solution. Solution. The only special constraint we have is constraint D, which is S3 greater than equals to 10. So the first thing is to reduce the capacity of the constraint by the amount of units required to make the special constraint. Note the units required to make constraint x3 is 10. So now let's reduce this capacity by units required to make S3. So we have, you have 3x1 plus 12x2 plus 6x3 plus 12x2 plus 6x3 less than equals to 660 minus, if x3 is 10, so this is 6x3. So minus 6 multiplied by x3. And our x3 is 10. So this will be equals to 6 times 10, which is 60. If you subtract 60 from 660, you'll be left with 600. That means the constraint becomes 600. So for the second constraint, constraint B, we have 6x1 plus 6x2 plus 3x3 less than equal to 1230. So 6x1 plus 6x2 plus 3x3 less than equal to 1230 minus, we have 3x3, 3 multiplied by x3. So where x3 is 10, so you have 3 times 10, which is 3 times 10, that is 30. If you subtract 30 from 1230, you'll be left with 1200. So for the third constraint, constraint C, we have 6x1 plus 9x2 plus 9x3 less than equal to 990. 6x1 plus 9x2 plus 9x3 less than equal to 990 minus 9 times x3. 9 times x3. Where x3 is 10, you have 10. So 9 times 10, that would be 90. If you subtract 90 from 990, then you'll be left with 900. So we have reduced the capacity of each of the constraints by the amount of units required to make the special constraint product. Now, the next thing is to introduce slack. Let's introduce slack. Let me call this one step 1. Step 1, introduce slack variable. Introduce slacks variable. This is step 2. Step 2. We want to introduce slack variable. So now we have 3x1 plus 12x2 plus 6x3 plus, let's say, slack 1. Let S1 be the slack 1. Then we have less than equals to, you are left with 600 here. Then the second constraint, we have 6x1 plus 6x2 plus 3x3 plus slack 2 less than equals to, we are left with 1,200. Then the third one, we have 6x1 plus 9x2 plus 9x3 plus slack 3. Then less than equals to, we are left with 900. Now, we've introduced the slack variable. The next thing is to organize the problem in form of matrix with the coefficient of x1, x2, x3. Now, let's organize it into matrix form. We have x1, x2, x3. Then we have slack 1, slack 2, slack 3. Then we have constraint, solution quantity. Now, the first constraint, we have the coefficient of x1, 3, 12, 6. 3, 12, 6. The coefficient of slack 1 is 1, but no slack 2 and 3. Though the coefficient of slack 2 will be 0, and that of slack 3 will be 0 as well. So we have 3, 12. Then we have 6. We have slack 1. The coefficient of slack 1 is 1. No slack 2, no slack 3. So we have 600. So this is solution variable. So this is slack 1. For slack 2 now, back to the problem or the function. Back to the problem, we have 6 for x1, 6 for x2, 3 for x3. We don't have slack 1. That means coefficient of slack 1 will be 0. We have slack 2. Coefficient of slack 2 will be 1. No slack 3. And everything is 1,200. So we have 6, 6, 3, no slack 1. We have slack 2, no slack 3. Everything is 1,200. For slack 3, coefficient of x1, 6, s2, 9. This is s2, 9, s3, 9. No slack 1. That means coefficient of slack 1 will be 0. Coefficient of slack 2 will be 0. Then we have slack 3, which is 1. Then everything is 900. So we have 6, 9, 9. No slack 1. No slack 2. We have slack 3. Everything is 900. Then we have the objective function. Z equals to, what is our objective function? You want to maximize 5x1 plus 3x2 plus 4x3. So this is the function you want to maximize. There's no slack there. So x1, 5, s2, 3, s3, 4. Then we have 0, 0, 0, 0. Now, we've organized the problem into matrix form. Then the next step is to identify the pivot. The highest value, the highest constraint is 5. You divide this by the number in that highest column. So we have 600 divided by 3, that is 200. 1,200 divided by 6, divided by 6, 6 in 12, that is 2. 200 as well. 900 divided by 6, 900 divided by 6, that gives us 900 divided by 6, we have 150. Then our objective function, 0 divided by 5. 0 divided by 5 equal to 0. I've told you anyone with 0 or negative, that should be ignored. If you have watched my previous lecture on simplex method, so we ignore this one. So the list is this. So that means this is within that row will be our pivot. This is the row. It is this 6 we use to divide it to get the 150. So this is our pivot. Now, since this is our pivot, I've told you the x3 here will be replaced by x1. That means we are now having row x1, row x1. So divide every element in this row by 6. So we have 6 over 6, 9 over 6, 9 over 6, 0 over 6, 0 over 6, 1 over 6, 900 over 6. That means the new row S1 now 6 divided by 6, we have 1. 9 divided by 6, we have 1.5. This is 1.5. This is a 0. This is a 0. 1 divided by 6, we have a 0. Let me leave this as a fraction because the number, okay, let me just 0.17. 0. This is a 0. This is a 0. This is a 0.17. 900 divided by 6, that is 150. This is the new row x1. Now, let's have, if this is table 1, let's have table 2 now. Table 2. So we have solution variable. Solution variable S1, S2. This is our pivot row, which has now been replaced by x1. So we have solution variable S1, S2, and x1. So we have x1, x1, x2, x3, then s1, s2, s3, and solution quantity. So we have x1, x2, x3, then we have s1, s2, s3, and solution quantity. Then the value, our row x1 is 1, 1.5, 1.5, 0, 0, 0.17, and 150. Now, we also have the objective function row Z, the new row S1, row S1. Now, we have old row S1. Old row S1, we have 3, 12, 6, 1, 0, 0, 600. We have 3, 12, 6, 1, 0, 0, 600. That is the old row S1. Now, our pivot row, our pivot row is the new row SX1, which is 1, 1.5, 1.5, 0, 0, 0.17, and 150. That is our pivot row. We have 1, 1.5, 1.5 is 0, is 0, is 0.17, and 150. This is our pivot row. This is the pivot element after dividing the row, that row x1, after dividing it through by 6. So this is the pivot element. Our target is to turn this column to 0. You know, this is x1, x2, x3. This is s1, s2, s3, and this is solution quantity. Our target is to turn this to 0. If you have 3 minus 1, it will be 2, not equal to 0. For this to be 0, then you must have 3 here as well. So then that means you multiply this root all through by 3. So if you now have 3 times 1, that will be 3. 3 minus 3, that will be 0. So this is new row S1. Then 1.5 times 3, that will be 4.5. If you subtract 4.5 from 12, then you'll be left with 7.5. 7.5. 6 minus 4.5, that will be 1.5. 1.5. If you have 3 times 0 is 0. 1 minus 0 is 0. 3 times 0 is 0. 0 minus 0 is 0. 3 times 1.7. No, it was 1 over 6 that gave us 0.17. So if you multiply by 3, so you have 0.5. Then 3 times 150, that is 450. If you subtract 450 from 600, you'll be left with 150. So this is 150. That is our new row S1. Our new row S1, we have 0. Then we have 7.5. Then we have 1.5. Is 0, is 0. Then 0.5. And then you also have 150. Then let's have the new row S2. We have old row S2. What do we have in row S2 before? 6, 6, 3, 0, 1, 0, 1,200. 6, 6, 3, 0, 1, 0, 1,200. Our pivot row is 1, 1.5, 1.5 is 0, is 0, is 0.17, and 150. Then your target is to turn this pivot, this is the pivot element, to turn this column to 0. For this to be 0, that means you have to multiply this by 6, so that you'll be having 6 minus 6 equal to 0. So you multiply through by 6. 6 times 1, 6. 6 minus 6 is 0. This is new row S2. 6 times 1.5, that gives us 9. 6 minus 9, that is minus 3. 6 times 1.5, 6 times 1.5, that is 9. 3 minus 9, that is minus 6. 6 times 0 is 0. 0 minus 0 is 0. 6 times 0 is 0. Is 0, and 1 minus 0 is 1. 6 times 0.17, you have 1. No, it was 1 over 6 that gave us this. Let me retain 1 over 6. 1 over 6, the 1 over 6, that fraction that gave us this, to avoid a rounding off error. 1 over 6 times 6, that gave us 1. 0 minus 1, that is minus 1. Though if you use 0.17, if you multiply by 7, 0.17 times 6, if you multiply by this 6, to give you 1.02. If you have 0 minus 1.02, it will give you minus 1.02. It's still okay like that. You are still right. Then 6 times 150. That gave us 900. Subtract 900 from 1,200. You'll be left with 300. So here you have 300. This is the new row S2. So we have 0, minus 3, minus 6, 0, 1, minus 1, and 300. Our row S2, we have 0, minus 3, minus 6, then 0, 1, minus 1, and 300. Then our objective function row Z. Now, let's have the old row Z. Old row Z. Our old row Z is 5, 3, 4, 0, 0, 0, 0. 5, 3, 4, 0, 0, 0, 0. Our pivot row is 1, 1.5, 1.5, is 0, is 0, is 0.17, and 150. Now, this one is the pivot element. Our focus is to turn this to 0 by subtraction. If you have 5 minus 1 not equal to 0. For this to be 0, you must have 5 here. That means to have 5 here, you have to multiply this by 5 times 5. 5 times 1, that will be 5. 5 minus 5 is 0. That is new row Z. 5 times 1.5. 5 times 1.5. That gives us 7.5. Subtract 7.5 from 3. You have minus 4.5. Then 5 times 1.5. Then you have 7.5. Subtract 7.5 from 4. You have minus 3.5. Minus 3.5. Then 5 times is 0. Is 0. 0 minus is 0. Is 0. 5 times is 0 is 0. 0 minus is 0 is 0. 5 times 0.17. I want to avoid rounding off error. Let me use the fraction that give us this, 1 over 6. Though if you use 0.17, no problem. 1 over 6 times 5. You have 0.83. Subtract 0.83 from 0 minus 0.83. So you have minus 0.83. Then 5 times 150. 5 times 150. That gives us 750. 0 minus 750. You have minus 750. So our Z row now is this. So we have 0, minus 4.5, minus 3.5, then 0 is 0, minus 0.83, and then minus 750. Remember, I've told you that the optimal solution is reached at the level where all the variables in the objective function row is either 0 or negative. If you check, you have a 0, and this is negative, this is negative, this is a 0, this is a 0, this is negative, and this is also negative. The optimal production plan. Optimal production plan. The value of x1 is 150. That is to produce 150 units of x1. So to produce 150 units of x1, that means that will fetch us, since it is only x1 we have here, these are slack variables. That means that will give us the contribution, to fetch a contribution of 750 pounds sterling. Then plus I've told you you are going to add the units of special constraints. I remember for that special constraint we added from the beginning, the one we subtracted from the beginning, that is x3. That is to produce 10 units of x3. Remember our objective function was given to be 5x1 plus 3x2 plus 4x3. That was the objective function we want to maximize from the beginning of the question. So our x3 is 4. If x is 10, 4 multiplied by x3, which is 10, 4 times 10, that is 40. That means the contribution from that special constraint product is 40. That is contribution from that is 40 pounds sterling. If you add 40 to 750, then you'll be having 790. That is the total contribution. Now, let's verify. 5 multiplied by x1. Our x1 is 150. Plus 3 multiplied by no unit of S2 will be manufactured. S2 is 0 plus this. 5 times 150, that is 750. Plus 3 times 0 is 0. This is 40. 750 plus 40, that is 790. That is the total contribution from that. Now, this is S1. S1 is 150. S1 equal to 150 units. Remember, S1 was the slack we introduced to to the machine hours capacity. So this is the spare capacity. Since you have your S1 here, S1 is the spare capacity, that is spare machine capacity. S2 was also the slack variable we introduced to labor hours. So that means we are having 300 spare labor hours. So we have S1, not units. This is S1, which is spare machine hours. S2, we have 300 spare labor hours. We have 300 spare labor hours. We don't have S2 within this row. No, I mean, we don't have S3. So the only place we have S3 is this. So that means we have S3 here, which is the shadow price. We are having the shadow price of 0.83. S3 stands for shadow, that represents shadow price. So we have shadow price of 0.83 pounds sterling. That is, if you increase the key resources, the limited resources by 1, the contribution will increase by 0.83 pounds sterling. Please don't forget to like the video, share it with others. Also subscribe to the channel if you have not done so. Thanks for watching Ezeka.